All right, let's talk about the engines that power pretty much every modern application you use. Operational databases. Now, this isn't just a story about storing data. Oh no, it's really the story of a massive technological revolution. We're going to go on a journey from a world where one single model ruled everything to today's world where we have a whole toolbox of specialized solutions. Let's dive in.
A huge welcome from all of us here at Nexus. We are so excited to get into this chapter overview with you. We're going to unpack the big ideas behind modern databases, starting with where it all began and moving all the way to the cutting-edge stuff you're absolutely going to see out in the real world.
So here's the plan. First, we'll meet the granddaddy of them all, the relational database. Then we'll dig into the massive shift that gave rise to NoSQL. After that, we're going to take a quick tour of the most important database types out there today, and we'll wrap it all up by seeing how modern systems use all of them together in an approach called polyglot persistence.
You know, to really get where we are now, you have to understand where we came from. And for decades, and I mean decades, one model absolutely dominated the world of data, the Relational Database Management System, or RDBMS. This thing was the bedrock for everything. We're talking banking, business, you name it. If it was a critical application, you can bet it was running on an RDBMS.
So what made it so powerful? Well, its greatest strength was its structure. Everything was built on a super strict blueprint called a schema. It defined exactly what your tables looked like, down to every last row and column. And you know what? This rigidity wasn't a bug. It was the main feature. It's what guaranteed everything stayed consistent and made these systems unbelievably reliable. And that reliability was baked right in with something called ACID compliance. These four properties, atomicity, consistency, isolation, and durability, were like a sacred promise. Think about a bank transfer. ACID guarantees that the money either moves completely from one account to the other or the whole transaction fails and nothing happens. No in between. It's this rock-solid guarantee that made RDBMS the undisputed champ for so long. But then, the world changed. The internet didn't just grow, it exploded. Suddenly, data wasn't just neat and tidy anymore. It was messy, unpredictable, and coming in from a billion different places at once. The rigid, orderly world of the RDBMS was about to slam into a problem it was just never built to handle. Which brings us to the biggest question of this whole chapter. I mean, if the relational model and its ACID guarantees gave us this incredible reliability, why in the world would we ever need anything else? What could possibly have happened that was so big it forced us to rethink how we handle data from the ground up? Well, here's the heart of the problem. To get bigger, relational databases scaled up. You just bought a bigger, more powerful, and way more expensive server. But the internet needed to scale out. It needed to run on thousands of cheap commodity servers working together. And all of a sudden, that rigid schema, the very thing that was its greatest strength, became its biggest weakness. It was a bottleneck. So this new challenge didn't create just one single answer. Instead, it led to what you could call a Cambrian explosion of database technologies. We went from a world where we basically had one tool, a hammer, to a world where we have an entire toolbox. And every single tool is specialized for a very specific kind of job. First up in our toolbox, the key value store. This is the simplest of the bunch. Just think of a massive, super fast code check. You hand over your item, which is the value, let's say it's some user profile data, and you get a unique ticket back, which is the key. Need your data? Just show the key. That's it. It's built for one thing, incredibly fast lookups. Now, a lot of these databases like React use what's called a peer-to-peer architecture. This is cool because there's no single boss server in charge. That means there's no single point of failure. If one machine crashes, who cares? The rest of the system just keeps on chugging. It's designed from the ground up to be resilient at a huge scale. So when would you actually reach for this tool? It's perfect for things like a caching layer to make your app feel snappy, or for managing a user shopping cart on an e-commerce site. Anytime you just need to do a bazillion simple get this and save that operations as fast as humanly possible, the key value store is your absolute best friend. Okay, tool number 2. The document database. Now, if the last one was a code check, think of this one as a high-tech filing cabinet. Each document in the cabinet holds all the information about one thing, like a customer or a blog post. And here's the kicker. Every single document can have its own unique structure. There's no rigid schema. It is flexible by its very nature. And that flexibility is what makes document databases like MongoDB so incredibly powerful.
They're perfect for things like content management systems or for an e-commerce site where one product has totally different features than another. Basically, whenever your data is messy and doesn't fit into a neat little grid, a document database is probably what you're looking for. All right, prepare for a bit of a mind bender. In our next database type, the graph database, the relationships between your data points are just as important, sometimes even more important, than the data points themselves. This isn't just about storing things, it's about storing the connections between them. Think about people, places, and events, and all the ways they're linked together. With the popular graph database like Neo4j, it's all about speed. Instead of doing these really slow, complicated joins to connect different tables like you would in a relational system, you walk the graph. You hop from one data point to the next along its relationship path. It is purpose-built for navigating a web of connections. So what's this good for? Well, ever wonder how your social network can suggest friends of friends, or how an online store knows that people who bought this also bought that? That's a graph database at work. It's perfect for any problem that really boils down to answering the question, how are all these things connected? Our last stop on this little tour is the spatial database. These are the absolute specialists for anything to do with location. They are built to understand geometric concepts like points, lines, and polygons, and their whole job is to answer questions like, show me all the coffee shops within a 2-mile radius of my current location. Seriously. Anytime you've used your phone for GPS directions, checked a weather map to see where a storm is heading, or played a location-based game, you have been interacting with a spatial database. They are the engines that power our digital understanding of the physical world, with tools like PostgreSQL being a hugely popular open-source option. So, we've seen the old king, the RDBMS, and we've seen all these new specialized contenders that rose up to challenge it. So who wins? Which one is the best? Well, it turns out that's completely the wrong question to ask. The modern approach isn't about picking one winner. It's about using all of them. And this quote just nails the modern philosophy. The old idea that you could find one database to solve every single problem, that's gone. It's dead. Today's complex applications aren't built on one database, they're built on many. And that, my friends, is polyglot persistence, using multiple database technologies, the right tool for the right job, all inside a single application. Just look at how a modern e-commerce app might work. The supercritical customer account information that lives in a good old reliable RDBMS. All the unstructured product reviews and comments, that's perfect for a flexible document database. And the delivery routes for the drivers, a spatial database handles that, no problem. Each system does what it's best at, and they all work together to create one seamless experience. That is polyglot persistence in action. And that really brings us to the final thought I want to leave you with. As you go out there and start designing your own systems, your first thought shouldn't be which database should I use. The real question you should be asking is which combination of databases is the right set of tools for this specific job. How are you going to assemble your data toolkit? And that wraps up our tour of operational databases. What a ride, right? We've seen how we evolved from the superstructured world of the RDBMS to this incredibly rich and diverse ecosystem we have today. In our next chapter, we're going to look at MapReduce, the powerful engine that actually lets us process and analyze the enormous amounts of data that are stored across all these different systems. I'll see you there.